your reading assignment that you have, and you are going to look at the sample problem. The sample problem will always be the hardest problem, okay? The other problems that are behind the sample problem with the practice problems are always easier, but they want to expose you to a hard problem. So what you're going to do is you and your partner are going to look over this hard problem, diagnose it, talk about it to each other, and then make sure that you put things in your calculator to make sure that it works. Does everybody understand? When you get done, you're going to turn the page to the next page. On the next page, you will see the 4 practice problems that we are going to do. Go ahead and start, and I'm going to go to the lab. This here is
really is.
Even you know, you want that person, you the influence. That makes yeah, because that I'm on the average salary. Oh, I'm just because there's okay, this ain't. So they use this.
All right, so if we look at on page 61, it has a question and it says, the famous gateway of the West Arch in Minnesota is about 192 meters tall at its highest point. Sally the stuntman jumps off the top of the arch. If you take Sally 6.4 seconds to land on the safety pad at the base of the arch, what is her acceleration? We are on page 61. So here it tells us velocity initial is 0 because she's standing there, right, guys? Change in y is 192 meters down. And the reason that is for is because she's on the top and she wants to jump off, right? So she's going to go in a negative place. The time that it says that she does this is 6.4 seconds. We are looking for acceleration and we're also looking for velocity final. So what they do is they give you a little equation for acceleration, okay? Now, unless I ask you for acceleration, we're going to have gravity is going to be our acceleration, 9.81 meters per second squared. But this one here is basically just showing you the calculations for this problem. You're probably never going to have to do this type of problem. But down here, you'll see acceleration is 2 times negative 192. That's her y, change in y. Minus 0 meters per second, that is her velocity initial, and they're timesing it by the change in time, which is 6.4 seconds, and then they're dividing that by the change in time squared. So what they've done is they have taken the equation of change in y, and they've moved it around to find the variable for acceleration instead. Just open it up. And so once they do that, then they have their number. Once they find their number, then they can go in and they can find the velocity final. Does anybody have any questions about how to do this math? Did you put this in the calculator? Do you know how to put it in the calculator and make it give you the number you're supposed to get? Is everybody good? Okay, turn the page. So what you're going to do now in your ISM book, so last rotation, you were in the lab room and you did section review, right, for the chapter. Draw a line under it. And then what you're going to do now is you're going to say page 62, practice. Okay. Now, the reason why we're doing this for is so that when you're reviewing tonight for the test, you will need to know, hey, I need to go back to this and look at this a little bit more. Maybe if you were in the back of the room and you were doing the section review and it's broken down into sections, and maybe you picked 1 or 2 from each section to see how you could do. Maybe you need to make sure you have to refer back so you understand it. This is how you do it. Okay, everybody good? So the first one says a robot probe drops the camera off the rim of a 239-meter high cliff on Mars, where the free fall acceleration is negative 3.7 meters per second squared. So the first thing it tells you is find the velocity in which the camera hits the ground and find the time required to hit the ground. So what kind of variables do we have so far? What do we know? Okay, and the height of the cliff is what variable? How high is the cliff is for the change in the y-axis. Everybody good so far? Okay. What is my velocity initial? She's not doing anything, is she? It's negative because she's jumping off of it. When she jumps, and this is the thing, when you're talking about acceleration and you're talking about y-axis, you're talking about it being up there, but then she's coming down, right? And this will make sense because acceleration is going to be a negative, right? What is the acceleration for her? Now, does it make sense to you if the acceleration is negative, that the y-axis would be negative also? Because what's going on is it's wanting to pull her down in that direction. Yes. I said it's a woman, didn't I? It is not a woman, it's a robot. I apologize. No, you're right. You're right. Okay, so what formula are we going to try to use for this? What are we looking for? Velocity final. Okay? Velocity final is the square root of velocity initial squared plus 2 times the acceleration times the change in y. It is a plus. I do that so I know it's not t for time, because I always do that just to make sure I understand it's a plus. Is everybody good so far? Yeah, how do you figure out what formula you use? Is you have to look and see what variables that you have and what have you used in the past to be able to find what you're looking for.
So where is
We didn't use that one in this section. Oh, I'm sorry?
where is like the list of formulas?
It should be in the back page of your ISM. Because every time we've been putting formulas down, we've been putting it back there. If you look, we used this formula, I think either last section or the section before. So I think it was in section 2, babe. And that's where we have this formula at.
So is there anywhere in this book that the formula is done?
No, ma'am. I think it's completely throughout. Okay. So we used this before in section 2. Had nothing to do with free fall, but it was in section 2. Right, guys? So here we are. Square root, right? Now, when we're doing a square root, we don't want to put the negative signs in, do we? Plus, we have 2 negatives, which makes a positive. Okay. So we have 0 meters per second squared plus 2 times negative 3.7 meters per second. I'm not going to put the negative here because if I put it in my calculator, it's going to give me an error. And then 239 meters. Go ahead and put that in your calculator and write down what you have for your answer. Okay. Fantastic. So we had went through and we figured out what you want to
I'm thinking, right?
Huh?
She said, you guys
Okay, so 42.1, is that a positive or a negative?
Positive. Negative. Yeah, what's that?
Okay, that's for A. Are y'all working on B? Because that's what you should have done. I just went by and checked everybody's for A that had it done. And now, right now, we're going to B. So B tells us, find the time required to hit the ground. Right, guys? So B, what variable, what are we looking for? Time, change in time, right? What is the formula I'm going to use for change in time? You're going to be using this all the time. You're going to be using that most of the time when we're talking about a free fall, and you're going to be using this question, this variable, better yet, this formula most of the time for free fall. These two go interchangeable. Okay? So my velocity final is my answer, correct? So I have a negative 42.1 meters per second squared. Subtracting my velocity initial, which is 0 meters per second, divided by my acceleration. They gave me acceleration negative 3.7 meters per second squared. And put that in your calculator. There is answer to these. Time's up. Alright, so what did you get for an answer? 11.4 seconds. And I did 11 seconds. Does it matter? No. Do you have 11?
Yeah.
0.4? Mine's 11. Doesn't matter. All right. So now you're working on question number 2, please. Okay. Question number 2 says a flower pot falls from a windowsill 25 meters above the sidewalk. How fast is the flower pot moving when it strikes the ground? What are we looking for? The change in Y, or better yet, it's free falling, right? I like that. So we're not looking for acceleration, but we are looking for what? We have the change in Y negative 25 meters, right? Now, since you said we're trying to find acceleration, ma'am, okay, it doesn't tell us enough information for finding acceleration, does it? Does it? So when it does not, that is when you use 9.81 meters per second squared, okay? So let's go ahead and put acceleration down, negative 9.8 meters per second squared, okay? And then also, what is our velocity initial? 0 meters per second. So, now that we have that, what's the next thing we need to find? Okay, so if you cannot do the math to find acceleration, Josh, it will be gravity. Negative 9.8 meters per second squared is what you have for gravity here on Earth.
So is this the one that you actually have to square? Like you should put it in the place?
No, ma'am. So the only time that you'll do that, and that's a really good question, on the test tomorrow, the only time you square something, see how this says meters per second squared? This you don't square because it's part of the measurement. The only time that you square it is in the equation that tells you have to square it. And we're going to get to that in just a minute. So remind me when we get there. So the first thing we're going to look for is velocity final. We've already done velocity final before in the last question. What formula did we use? We used the square root of velocity initial plus 2 times acceleration in the change in y. Remember what I'm saying? When we're doing, ma'am, it is. Thank you very much.
That's what I put.
God bless us. Thank you, baby. I appreciate that. Don't erase it. Please correct me. So back to her question before. If you went in here and you did velocity initial and you didn't put the square in there, is your answer going to be correct? No, right? So let's write our question down. So our velocity one is 0 meters per second, and we're going to square that, right? Because that's what it says to do. We're going to add 2 times acceleration, which is your negative 9.8 meters per second squared. I'm not going to put the sign here because I use this to tell me how to put it in the calculator. Okay? And then after that, I'm going to be changing y, which is a negative 25 meters. It's a negative, but I didn't put it in there because I want to use it for my calculator. So go ahead and put in your calculator and put your answer down that you get. Okay. Don't put your negatives. Okay. So do you see how I do that? That's good. Now write it that way because I know it's negative, but if I write the negative in, I always up. What did you get? Good. Okay. So on this one, you got 22.1 meters per second. It's going to be a negative 22.1 meters per second. Now we're going to do B again. What are we looking for again on B? Just like we did before. We're looking for change in time, right, guys? Okay. Change in time equals velocity final minus velocity initial over acceleration. All right. Everybody good with the change in time part? Velocity final minus velocity initial over acceleration. My velocity final is negative 22.1, right? Meters per second. I'm going to subtract that by my velocity initial, which is 0. And I'm going to divide that by my acceleration, which is negative 9.8 meters per second squared. So I'm going to do alpha y enter, open bracket, negative 22.1, close bracket, minus, open bracket 0, close bracket, down, negative 9.8. And what did y'all get? I got 2.255102041. Is that what you got? So the answer to that would be how many seconds? 2.5? 2. What else would you put on there, you think? 2.3. Now, I disagree with 2.3. Because here am I, it's 2.2551. So with me, I've always looked at the one on the right as a 5. Okay, can't decide. Go over to the next one. It's a 5. Can't decide. The next one is a 1. So that means I don't round up. All right, this is my answer. Right, guys? Is that the answer you got? Okay. I'm looking at this number to figure out what I'm going to do. And this is just the way that I'm educated. Maybe you're educated different. Maybe math's different. Physics might be different than math. When I'm figuring out I'm rounding, I look over here. If it is below a 4, I keep it, or if it's a 5, I look to the number to the right of it. That's a 5, so I can't decide. I look to a 5 again, and I can't decide. And so I look to a 1, and that tells me I don't round up. Do you not do that in math? Y'all, I need your help. Do you do that in math?
It's 3.25. You count that up to 2.3.
Yeah. Okay, and who is that?
Any math class I've ever taken.
Fantastic. Okay, cool. That is definitely a question. I did not round up. You rounded up, does it matter? It won't matter to me. It don't matter to me. How about that? Because we already had that discussion earlier today. Don't matter if you're close or not, as long as you know what the number is. I think I've had people before just write the whole number down and just call it a day. Because you know what? Hey, it can't be wrong. Okay. Is there anything else we need to do with that question? Everybody good? Let's go to question number 3 now. God bless us. That is great. Okay. Number 3 says, a tennis ball is thrown vertically upward with the initial velocity of a positive 8.0 meters per second. What will the ball speed be when it returns to its starting point? Okay. So my velocity initial is a positive 8.0 meters per second. They're throwing the tennis ball up in the air, correct? My acceleration is negative 9.81 meters per second squared. There, I got it again. That has to do with gravity because gravity is trying to pull it down. Change in y is 0. I am looking for velocity final. I'm going to use the same equation I've used before. Velocity initial squared plus 2 times acceleration in the change in y. So I'm going to do square root. I'm going to do 8.0 meters per second squared plus 2 times acceleration. And I'm not going to put the negative sign in, right, guys? Because I can't do it in my calculator. And I'm going to change in y, which is 0. All right, what did you get? 8. Is that a negative or a positive? Negative. Can we all agree at 8 meters per second? Negative. Fantastic. Now what we're going to do this time, again, what we've done before, we're looking for what? Looking for change in time, guys. Velocity final minus velocity initial over acceleration.
Mom, are you funny? I did not get 8. We both got 2.8 and we put it in.
Did you square your 8.0?
That's what I got.
Okay. All right, so velocity final is our answer that we had before minus our velocity initial, which is 8 divided by negative 9.8. What do you get for the answer for that one? Negative 8 minus 8 divided by negative 9.8. And you should get 1.63 seconds. 1.63 seconds. I did negative 8 meters per second, subtract 8. My friend, people, take your books, put them in the back. Textbooks in the back, guys. People in the back, wipe your tables down and come to the front.
What? I don't know, funny thing, I'm talking about that schedule. Oh, no. You done with this?
What? Yeah.
Elena.